Hello everyone. So today's lead code problem of the day is zero array transformation 3. So if you haven't seen my zero array transformation one, I'll keep the link in the description as well as in the I button. Go and have a look in that particular problem and then come to this problem because this is very similar to that problem. This has extra stuff which we will discuss. We have given an integer array nums of length n and a 2D array queries where query of I is left index and right index. Each query represents the following actions on num. Decrement the value at each index in the range left to right in the nums by at most 1. The amount by which the value is decremented can be chosen independently. So let's first understand what is these 2 points. 0, 2. So it's saying that decrementing at most 1. So we can either decrease by 0 or decrease by 1. Independently means we can choose any index in the range left to right. So if the left is 0, right is 2, we can choose this to be decreased because we have to make the array 0. So we'll choose to make it decrease it. We will not choose to decrease it because it's already 0, and we will choose to decrease it because it's non-zero. So it will become 1. So this is what these 2 points are trying to convey. So what do we have to return? Return the maximum number of elements that can be removed from the queries. So there are multiple queries and we have to return maximum number of queries such that num can still be converted into zero array. So let's see the test cases. So for the test case number 1, this is the input and the queries are these are the queries. So 0 to 2 means we have to decrease from 0 to 2. So if we decrease, it will become 0. I choose not to decrease it because it's already 0. So it will be 0. I choose to decrease this one. And the second one is 0 to 2. Again, I'll choose to decrease this. So it will become 0. This is already 0. This will become 0. So the third is 1 comma 1. So this. But do we need this? No, because we have already made the array 0 array with the help of the first two queries itself. So the output will be 1 because we don't need this particular query for getting the array to 0 array. So we return 1. So let's go to the second example. Query is 0 to 3. So 0 to 3 means there is only one query. I choose to decrease this. I choose also to decrease this. This will be 1, this will be 2, this will be 3. So there we have exhausted for all the queries. So if you see, it's not a zero array, so we have to return -1. After iterating to all the queries, we are not able to make the array 0, then we have to return -1. So for this particular example, the first is 1 to 3. So this is the range left to right. So we choose to decrease all three of them because it's non-zero. So it will become this after the first query. So let's see the second query, 0 to 2. Yes, we can decrease this. This is already 0. So it will become this. So after first query is this, second is this. So do we need any more queries? No, we don't need because it's already 0 array. So this one and this one we don't require. So we have to return 2. So let's see the thought process behind this. So let's go through what I'm trying to say here is that if one query starting, two queries are starting at the same starting index, let's suppose ith index, but the first query is going to, let's suppose 10, and this is going to 7. Do we consider this or this? Which is the better query? I meant to say. This is the better query because it's starting at the same index, but it's going farther. So between this, if we have a choice, which one would we choose? Of course, this one we would choose. So for this is the thought process for the uh, queries starting at the same index, but one is going further and the other is not going that much further. So we'll take the query which is going further. For this particular example, thought process, the first query is completely overlapping the smaller query. So would we take the smaller query or would we take the larger query? Here also we would prefer to take this because it's starting early and it's ending after the second query. So if we have a choice to select from these two queries, we would always choose this greedily. So let's see, this is the second example in the test cases. So this is the array and this is the uh, what do you say, graphical representation of all the queries. So if you see, if you traverse from 0 to 3, you can see that all the queries are sorted in the graphic, in the pictorial representation. You can see it's starting from 0, it's 2, it's 1, 1, 1. So but if you check the array, if you traverse array from 0 to n, suppose this is starting from 1, this is starting from 0, so it's not in a sorted order. So the first thing that we need to do is to sort the queries so that we can we can use this particular insight as well as this insight, so that we choose greedily which query we need. So let's the query can be in four stages. I explained that. So if we are at index 0, so have you seen this or this particular query? No, we have only seen this. So this and this is in unseen state, but this one we have seen but is not in use, because we just came here and we just saw that yes, this is in the interval 0 to some x, so it's starting from 0, we saw that. And seen not used means if we have seen this but we did not use, because redundancy can happen. So in this example, if we see, to make this array 1 1 1 1, we can take this particular query and this particular query. Do we need this one? No. Do we need this one? No. But we have seen them. We have seen them. We have seen them. So seen not used, but this is seen and used. What is invalid or expired state? I'll explain you that. So let's suppose we are at index 2, or let's suppose index 3. Index 2 will suppose. So at this particular index, we'll see that these two queries are going to expire after 2. So that's it. That is what we say invalid or expired state. So what observations did we make? So instead of using all the intervals we have seen till now, so whatever intervals we have seen till now, we will only use the necessary ones which are still valid. So we have to first check whether it's expired or not, whether it's valid or not, and we only use the intervals which we require, which are necessary, and not all of them. And we also have to keep track of queries with the maximum endpoint. For using this insight, we have to keep the ending index as a parameter, so that we have a check that yes, for these two queries, this one is better, keeping an eye on expiring query. So we are, I've explained you already. So we have to keep an eye for the expiring query. So if we are at index this, so we have to check, we have to remove these two queries. If we are using that, we have to remove this and this. If we are not using it, it doesn't matter. But if we are using it, we have to remove it. So we have to keep that in mind as well. So let's go through the algorithm first. I'll show you the dry run, then you can read the algorithm as well as code. It will be very easy after dry run, it would be the algorithm will be very easy after the dry run. So we are at index 0. This is starting and this is the ending. This is starting, which is 1, and this is ending, which is 3. This is 1, this is 2, this is 1, and this is 3. So at 0, we are currently at 0. So what all intervals are starting from 0? Only 1. So this is the available queue. We are making two queues. We are making one max heap and one mini heap. Max heap because we want to maximize the endpoint, and min heap because if we are at this index, we want to see which is the ending index and we want to remove it. We have to pop it so that we don't have to traverse through entire uh, heap just to remove the invalid or expired queries. So for that we use min heap, and for this particular insight we use max heap. So this will be 0 comma 2. This will be 0 comma 2, and at 0 index we have 1. So we at least need one query to make this 0. Do we have one query? No. But do we have any queries in the available queue? Yes, we have. So we'll remove this from here and we'll add that 0 to 2. So this has become 0 because we have one query which can resolve this. Now we'll go to index number 1. So how many queries are starting from index number 1? 3 queries. This, and this. So let's mark them. The order should be in max of the ending. So this is from 1 to 3, this is from 1 to 2, and this is from 1 to 3. So 1 to 2 will be the I will take the max heap, the top element at the bottom. So let's take that 1 to 3, 1 to 3, and this is 1 to 2. And the element at index number 1 is 2. So we need at least two queries. This will resolve it to become 1, but we need one more query to resolve it to 0. So for that, we'll ask available queue, does it have any more queries? Yes, we have 3. So, but we don't need 3, we only need one query. So we'll remove the top element and we'll give it to 1, 2, 3. So minimum should be down and maximum should be up because this is a minimum, this is 3, this is 2, this is 3. So it's a min heap, here it's a max heap. So this can resolve to 0. Now we come to index number 2, and at every index we'll check if any queries are expiring. So at this particular index, is any query expiring? No. At this, no. So at this, yes, but before removing the expired queries, we need to process this because this is expiring after 2, not at 2. So we'll process this, then before going to 3 we'll remove the expired queries. Okay, so we have two queries, so it will resolve it to 1. Because we have two queries, it will do -2, but we need one more. So we'll ask available queue. Yes, it has 2, so it will give one of it. So it will give the top element, 1 comma 3 will come. So now we have 3, so it will become 0. So now before going to 3, we'll check in the min heap if there are any other, if there are queries that are going to expire or going to expire. So we'll check, this is the top element, so we'll check the top element. Yes, this is going to expire, so we'll remove this. Now we'll check whether this is going to expire. No, this is, we are at 2, so it's not going to expire. So we'll bring this down, and now we are at index 3. Any query starting from 3? No. So we check the number is 1, we have two queries, so it can easily be resolved and it will become 0. So how many queries did we use? We used 1, 2, and the 0 comma 2 query. 0 comma 2 query. So three queries we used and one was not required. So the output would be, we have to return the maximum we can delete. So maximum we can delete is one query. So we'll return one as the answer. So let's see the algorithm for the same and the code. So firstly, we'll sort the queries in the starting index, which is query of 0. We'll sort it based on query of 0. After that, we'll add all the queries starting from ith index into the max heap. Okay. We will check if we have necessary queries in the used heap. Used heap is the main heap that we were going through the dry run for. To make the element as at index I is equal to 0. So this was used to make the element at I is equal to 0. If we did not have necessary queries, we will borrow it from available query. We will, if not present in max heap as well, if suppose it was, let's suppose here at this particular index, it was not 3, it was not 3, it was 5, suppose. It was 5. So do we have 5 queries? No, we totally don't have 5 queries. So we'll return -1 directly. So we'll check first here how many queries did we have. Suppose we had two queries, and in this we had two queries extra. So we'll check this. No, we don't have. So we'll ask available queries set. So it has, but it only has two. So 2 plus 2 is 4, which is less than 5. So we'll return -1 and we don't do any further processing. And after we have done the processing, we will remove all the expired queries from the used heap, as I've explained in the try run. So we'll make two heaps. One will be used with use query, which is the min heap, and the other is available query, which is max heap. Okay, we'll sort the queries based on the 0th index, which is starting index. We'll take two index pointers. I would say this is for the query. Which query are we currently at? Because in at a particular index I, it could be that multiple queries may be possible. For instance, in this particular example, at I is equal to 1, there are 1, 2, 3 queries which are starting. So we have to pass through every query and add it to available query. For maintaining the index ordering, we take a index pointer for the query as well. And this is the applied count. So whenever we are borrowing queries from available queue, we will increase the applied count, which means that we have used a query from the available queue. So we'll first push all the queries starting from ith index. That is simple. Then we'll add available queries to used query if used query isn't sufficient. So first we'll check if used query is sufficient or not. From this, we'll check used query dot size is less than nums of I. If it's not, then we'll directly empty the used the will directly remove the expiring queries. If it's insufficient, we have to uh, pull from the available queue. Then we have to offer it to used queue, and we have to increase the applied count because we are borrowing from available queue. So after this processing, after borrowing from available queue as well, we are not able to satisfy this condition, which means we are not able to make that particular index as 0. We will return -1. Then after that, what is the last step? We have to remove all the expired queries from the used heap. So we'll go through use heap and we'll remove at that particular index I. Then we'll get the applied count applied count is how many we used. In this particular example it was 3. So we'll directly subtract the length of the query, which was 4, minus 3, which is 1. So we did not use 1, so we can remove this. We can remove this number of queries from the query set. So this is the complete algorithm and the code. The link for the code and the notes would be in the description. Please like, share and subscribe.